What is the pH of a 0.1 molar hydrochloric acid solution? You what? It is one. Can do that in your head, can't you? Yeah? So what is the correct answer? 1. How did you do that? Well, pH equals minus log of the proton concentration. Here the proton concentration is 0.1. And the important thing is we always... There's one down here if you like. The proton concentration, we are always dealing with molar. And I come back to that in a while when we discuss a slightly different example. So we have minus log of 0.1. We have minus, and log of 0.1 is negative 1. So I have minus times minus, and that gives plus 1. So pH equals 1. If you got that, excellent. Sorry? Say again? Why did I do 2 steps? Oh, this one here, you mean? This bit here. Oh, it's just for people who want to see how it's done. Yeah? It's not, you don't have to do that. Okay. That was easy. Now here. What is the pOH? pOH of a 0.1 molar hydrochloric acid solution. What is the pOH?
It's just the after trying to fill the spaces.
So have you got something? Have you got something for that? What is the pOH of this? 13. Huh? 13? 13? 13.2, no? Well, pOH means how much hydroxide ions are there. Yeah? So we say pH equals minus log of the proton concentration, and pOH means minus log of the hydroxide ions. And there is another very convenient equation. pH plus pOH is always 14. Yeah? And I want you to remember that. pH and pOH is always 14. Always. Without exception.
So should you do your pH first and just deduct that from your pOH and you would always have the right answer?
Debbie, loud. 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 Say loud. You are absolutely right. Go on.
I can't remember now.
No, you said it right. Go on.
Oh,
Go on.
I just said, so if the pH plus the pOH is always 14, do you work out the pH first and then just deduct that from the pOH to get your answer? And is it always the same method?
Absolutely. So what you do here is you have been given a 0.1 molar hydrochloric acid solution. We've calculated the pH. The pH equals 1, you said earlier. Yeah? We are now looking for the pOH. And we know that pH plus pOH equals 14. So therefore, we know that the pOH in this case must be 13. Because 13 add 1 gives you the magic 14. Yeah? That's how it works. Very simple. Okay, here's another one. What is the pOH of a 0.1 molar sodium hydroxide solution? What is the pH of that guy? Is it an acid or a base? It's a base. So this base, what would that do in? Yes, yes, you're absolutely right. Yeah? So it produces base, it produces hydroxide, OH minus. So we are looking at pOH equals minus log of the OH minus. This is here 0.1 molar. We always have it in molar. And therefore the pOH would be, what is the pOH in this case? 1. Yeah? So if it is a base, we are usually looking at the pOH. If it is an acid, we are looking at the pH. Because the acid produces H, protons, and the base produces OH, hydroxide ions. Can you calculate the pH of this solution? What's the pH? Loud? 13. Why? Exactly, because 13 add 1, from the pH gives us the magic 14. Yeah? Pretty simple and straightforward, isn't it? Want another one? Not really. Oh, at least you're honest. What is the pH of 30 micromolar hydrochloric acid solution? That was one of the stumbling blocks that people came across in the little test. Debbie, loud! Loud! Go on! Yes!
What are we doing?
You are right. So what do you have to do with that? What do you have to do with that? Loud? You have to convert it to molar, exactly. Because the pH thing, that only works with molar. It doesn't work with micromolar. Yeah? So you have to convert that into 30 times 10 to the minus 6 molar. So pH equals minus log of 30 times 10 to the minus 6. That's our proton concentration. And when you do that, what does that give you? Gives you a pH of, say again please, 4.52. Actually, what's the unit for pH? Unit for pH? No unit, exactly. So here the pH is 4.52. What is the pOH of this solution? pOH? So pH is 14, take away 4.52, gives you 9.4H. Do you get that? Yeah? Simple. Very simple. Here's another one. What is the pH of 1 nanomolar hydrochloric acid? Do you get it? Yeah, nano is 9. Did you get it? Did you get it? Yeah? What did you get? 9. How many of you got 9? Hands up. How many of you got something else? Now that's quite interesting. Can I ask you a couple of very stupid questions? What is HCl? It's an acid. When you put an acid in water, what should the pH do? Go up or down? It goes down. What is the pH of water? So the pH is 7 of water. And you just told me that the pH should go down when you put an acid in water. Yeah? But you just told me that when you put this acid, this 1 nanomolar acid into water, you get a pH of 9. Are you lying? Sorry? It's a very mild acid. You got what? You got piles. What? Do you see the problem that I have with you guys? On one hand, you tell me you put an acid in and the pH should go below 7. But you just told me that your pH is all of a sudden 9, which is basic. Where is... Sorry? Will the water change it? That's a very interesting question.
So the concentration goes up.
What is... Both of you are getting close to it.
Doesn't make the water auto-ionized.
The water auto-ionizes. Yes? So the proton concentration in pure water, is 1 times 10 to the minus 7 molar. Yeah? Remember that? And now my acid concentration, I do that in a different color. My acid concentration, that's this one here, is 1 times 10 to the minus 9 molar. Yeah? So, when I put them both together, I have 1 times 10 to the minus 7 plus 1 times 10 to the minus 9. 1 times 10 to the minus 7 plus 1 times 10 to the minus 9 molar. Can you do that on your calculator? I can do that without. 1.01 times 10 to the minus 7 molar. Is that right? Did you get that? Yeah? That is my concentration of protons. And now I do simply the pH of that. pH equals minus log of this, basically. And what do you get? Log of 1.01 times 10 to the minus 7. What's that? Six point 99? 996, 6.99, something like that. 996, you said. Is that below 7 or above 7? It is below 7. Yee-hee! The theory works. Thank God for that, because it would be really bizarre if we put acid into water and all of a sudden it becomes basic. Can't work like that. Does that make sense? Yeah? So, the rule is, if it is in the range of probably micro or something like that, micromolar or below, we have to calculate the water in. If it is above micromolar, it doesn't matter. The water is, it's insignificant what the protons in the water do, because there are so few there that it doesn't matter. Does it make sense? Yeah? I caught out a few of my colleagues, so don't worry. You are not alone with your assumption at the beginning that it is pH 9. I gave this a few of my colleagues, and most of them said it's pH 9. And I said to them, are you sure? And they were happy to swear on their life and the life of their children that it's pH 9. I should have done some bets or something like that. Here's another question for you, which people found slightly disturbing in the little test that we did. In this case, I gave you a different acid. I gave you H2SO4. So, bless you, sulfuric acid. And this sulfuric acid in water is not losing just one proton, but two protons. So what happens if you put that into water? We get the sulfate ion is double negatively charged, and we get, let me remove this guy here, and we get two protons from that guy. Yeah? Now, sorry? H4? Well, yes. If you add water, it would be H3O plus twice. But I didn't want to complicate things here. So, if I have a 0.1 molar H2SO4, what is my proton concentration? Well, What's the proton concentration in this case? I have 0.1 mole per liter of this sulfuric acid. How many protons do I have? Shout out loud. 0.2 molar, exactly. So my proton concentration is 0.2 molar. Because each molecule of this sulfuric acid gives me 2 protons. So therefore, if I have 0.1 of the sulfuric acid, I get 0.2 molar of the protons. And now, if I ask you, calculate the pH. Oh my God. pH of a 0.1 molar sulfuric acid solution, I need to remember that for each 0.1 molar sulfuric acid, I get actually 0.2 molar protons. So therefore, my pH equals minus log of 0.2. Yeah? What does that give you? pH equals, what does it give you? Say again? 0.699 or 0.7 or something like that. Absolutely right, bless you. So that's the pH. What's the pOH? What's the pOH? 13.3. Exactly. Yeah? Does that make sense? What is the pH of a 5 molar H2SO4 solution? What's the pH of a 5 molar sulfuric acid solution? Got it? Sorry? Can you or can't you?
I think you can. My chemistry teacher said I could.
How many moles of protons do we have? So this gives us 10 molar solution of protons, right? Yeah? Are you happy with that? So let's just simply take the pH. pH equals minus log of 10. What do you get? So the pH equals -1. Huh? Negative pH. Can we have a negative pH? Yes? Who thinks yes? Hands up. Who thinks no is forbidden? Taboo. Yeah? Be brave. Be brave. Who thinks no? Actually, you can have a negative pH. It's not forbidden. It's not taboo. You can have a negative pH, although very often this is not as straightforward as it looks here. Because what happens is, if it is too much protons there, what they will do is they will say, no, actually, it's overcrowded in protons, and therefore, what you would have if you put, you can do that with HCl as well. Let's do HCl. What usually would happen, well, let me do that in a slightly different way. HCl would usually dissociate into H plus and Cl minus. Yeah? But if you have too many H plus, if you've got too many H plus, these H plus then will go backwards. They will bind to the chloride and form HCl again, if there's too much of the H plus there. Now, we have a very interesting system here. It looks very, very primitive. What is this guy here? What is it? Acid or base? It's an acid. If we have this reaction, heaven's sake. What is this guy here? This chloride is an ion. It's a negatively charged, but it accepts a proton, doesn't it, here? So in this case, it would be a base. Yeah? So if something accepts a proton, it's a base. If something donates a proton, it's an acid. Now these two, HCl and Cl minus, are related to each other. They're sort of twins. Well, not twins, they are cousins. This is also called a conjugate acid-base pair. And a conjugate acid-base pair differs only by the proton. So, for example, if I have NH3 and I say this is the base, what would be the conjugate acid to that? Loud? Exactly. The conjugate acid to that would be NH4 plus. NH3 as a base could accept a proton and become NH4 plus. NH4 plus could give off a proton, and therefore it would be the acid, and become NH3. Yeah? Okay. We've got water. And I say water is the base. What is the conjugate acid? Loud? Say again, the last one? No. So the base can pick up a proton. Yeah, that's what a base does. So H plus, and it becomes H3O plus, exactly, a hydronium. So that's the acid. Now the acid, of course, I can write that also in that direction. The acid can donate, the H3O plus can give off a proton, this guy here, and is converted into a base. H2O, and now this is my acid. What is the associated base? Loud? Hydroxide ion. OH minus. Because the acid gives off a proton. Yeah? So the OH minus here, the OH minus gets hold of a proton and is converted into the acid. Yeah? For heaven's sake, could that Klapper not make up his mind? Here he says H2O is a base. Here he says H2O is an acid. What the is it now? It can do both. It's sort of, how shall I say that? It's batting for both sides. Yeah? So it can be either base or acid, and as you rightly said, this is called amphoteric. Ampho means both. Not decided, sitting on the fence. Yeah? Depending on what is available. Does it make sense? Now you have a definition of amphoteric. It's a compound that can both act as a base and an acid. Any questions? Are you happy with that? HSO4 minus. Now tell me, acid or base? Acid, base, or both? It's both. It's amphoteric. Why? Because on one hand, it can accept a proton and become H2SO4. So that would be the acid to the base. Or it could give off a proton and become the double negatively loaded. So this then would be here, that would be the base to the acid. So HSO4 minus is again an amphoteric molecule. Okay? So, with what you've learned today, hopefully, what you worked out yourself today, have a go at the test again. Yeah? Have a go at the test. Scrap the again. But I want all submissions in by Wednesday.